There is a massive revolution happening in artificial intelligence, but it's not where you might think. It's not in some giant far-off data center. Nope, it's happening right here, on your desk, in your hands. A huge migration of AI is taking place, moving from the cloud to our personal computers, and honestly, it's about to change everything.
All right, so here's how we're going to break this all down. First, we'll dig into the hidden costs of AI. Then, we'll explore this big shift to running it locally. After that, we'll talk about a new way to measure efficiency, jump into the hardware showdown, and finally, we'll get to the most important part, why this all matters to you. So to really get where AI is going, we first have to talk about where it is right now. And honestly, the current AI boom is built on the cloud, and that foundation is starting to show some serious cracks. Okay, get ready for this number. 70%. By 2030, analysts are projecting that a staggering 70% of all new demand for data center capacity will come from AI. That's just not sustainable. It's a huge problem, not just technically, but environmentally and economically. It's like trying to power a city that's constantly growing with just a couple of power plants. Eventually, you're going to hit a wall. And that brings us to the big multi-trillion-dollar question, right? The cloud-first model got the AI revolution started, but it can't carry it forward. As we scale up from making billions of AI requests a day to making trillions, the energy, the cost, the resources, it all becomes a massive problem. So what do?
The answer isn't to just build more and more data centers. It's to find a completely different path, and that path leads away from the cloud. The solution is a fundamental change in how we think. We move the AI processing from those distant servers directly onto our own local devices.
The researchers behind this new study put it perfectly. We've seen this movie before. It's just like the historic shift from those giant room-sized mainframe computers to the personal computers that ended up on everyone's desk. That change happened when PCs became efficient enough for personal use, not when they became more powerful than the mainframes. AI is at that exact same turning point right now. So what's the actual difference? Cloud AI, that's what most of us are used to. It's centralized, you've got to be online, and you're sending your data to some third-party company. But local AI, that's a total game changer. It runs right on your device, it works even if you're offline, and this is the big one, your data stays private with you. Period.
And the engine powering this entire shift is right here on this chart. Over the past decade, the amount of memory in the hardware we buy has absolutely exploded. We're talking more than 126 times bigger. This is what makes it all possible. This huge jump in local memory is what allows our laptops and our phones to run the kind of powerful AI models that, until very recently, could only exist in the cloud.
Okay, so we can run AI on our devices. The hardware is there. But does that mean we should? Is it actually a good idea? To answer that, we need a new way to measure performance, one that goes beyond just raw speed. We basically need a new rulebook for this era of local AI. And researchers have come up with this brilliant new metric, intelligence per watt, or IPW. It's a simple idea, but it's powerful. It tells you exactly how much AI capability, how many correct answers you get for every single watt of power you use. It is the ultimate measure of AI efficiency. And just look at how fast things are moving. This chart shows that from 2023 to 2025, the IPW of local AI improved by a massive 5.3 times. This isn't some slow, gradual improvement. It's an explosion of efficiency, and it's happening because we're getting smarter AI models and more powerful local hardware at the same time. To put that into real-world terms, just look at the raw capability. Back in 2023, the best local AI was only as good as a top cloud model on about 23% of tasks. By 2024, that number jumps to almost half, and by 2025, it's projected to soar to over 71%. Local AI is catching up, and it is catching up fast. All this incredible progress brings the conversation out of the research lab and into the real world, to the chips we can actually buy and use. And this leads us right into a fascinating hardware battle, a showdown between two giants, Apple and NVIDIA. Now, if we look at the numbers for pure, raw efficiency, that intelligence per watt score we talked about, the specialized cloud hardware still has an edge. NVIDIA's massive B200 data center chip is about 1.4 times more power efficient than Apple's M4 Max consumer chip when they're running the exact same thing. But wait, efficiency isn't the whole story. As this Reddit user points out, Apple's chips have a secret weapon, unified memory. Think of it as a giant shared pool of memory that lets you avoid bottlenecks. What that means is you can run significantly bigger and more useful models than you could ever fit on a normal consumer GPU. It's an advantage of sheer capacity, not just speed. And what's so interesting is Apple's strategy here. They're going all in on making local AI on our devices better. But at the same time, we now know they're also building their own AI servers, their own private cloud, using those same M-series chips. They're betting on a future that is both local and cloud, all powered by their own custom silicon. Okay, so we've talked about the tech, the metrics, the hardware. Let's bring this all home. What's the real payoff here? Why does this big AI migration really matter to you, the person actually using it?
This might be the most important number in this entire explainer. Researchers looked at over 1 million real-world AI requests and found that nearly 89% of them can already be handled just fine by local AI models. Let that sink in. The vast majority of things we ask AI to do don't need a giant, power-hungry cloud server.
And the impact of actually doing this is enormous. This chart shows what happens when you use a hybrid system, one that smartly sends simple requests to local devices and only the hard stuff to the cloud. The result? A reduction in total energy use by more than 64%. That dramatically cuts costs and slashes AI's environmental footprint. So what does this all mean for you? Well, it means 4 game-changing benefits. First, you get real privacy because your personal data never has to leave your device. Second, you get total freedom with tools that work on a plane or in the subway. Third, you get instant speed with zero network lag. And finally, we all benefit from a lower global cost for AI, which just makes it better for everyone. So let's end with this thought. The first era of AI was defined by what we could access in the cloud. This next era, well, it's going to be defined by the intelligence we carry with us. As this great migration continues, moving AI from those huge data centers into the computers in our pockets and on our desks, you have to ask, what incredible new possibilities is this all going to unlock?